So we've been over a load of examples there. Hopefully you found those useful for mastering SUVAT. And we'll now have a look at an exam style question, which is going to be very similar. It's just one for you to have a go at and see if you can set up the parts of SUVAT for yourself. So we've got a tennis ball that's hit directly upwards. It leaves the racket at a velocity of 20 meters per second. And we're assuming the racket's at ground level, by the way. We want to find the height of that ball after 1 second. And then we're going to find the velocity of the ball 3 seconds after it's struck and state whether it's traveling upwards or downwards. So that's a good test if you've got your sign convention the right way, if you've got your positives and negatives right. Okay, so you may find these tricky if you haven't had much practice at SUVAT questions, but try setting it up just like I did earlier in the video. Draw yourself a little diagram, decide which way is going to be positive. This is going to be affected by gravity, isn't it, because it's been hit directly upwards. So first thing to notice is your acceleration here is due to gravity. Okay, so I'll give you a bit of a head start in this question. Think about your sign convention. Which way are you going to take as positive? Okay, basically you have to choose, is it upwards or downwards? Okay, but apply it consistently throughout the question. Write out SUVAT. What do you know? What do you need to find out? Choose your equation. Have a look in the formula book for the equations, or just wind back this video to the point where I listed them all out to choose the right equation. And then rearrange the equation for what you need. Okay. So really good practice to have a go at these questions. So if you've got a moment, even if you can only do the first part of getting the answers, it's still very useful. So have a quick go at doing this question now, and when you're done, we'll go over the answers. Okay, so hopefully you've had a moment to look over those that question, these two questions. So we'll have a look at the answers now. So for part A, let's draw ourselves a bit of a diagram of what's going on. The tennis ball is being hit upwards, so it starts down here. It ends up here somewhere. So this is the start, this is the end. It left at a velocity going upwards of 20 meters per second, left the racket. And it's traveled upwards for 1 second. And we want to know how high the ball is after 1 second. Okay, so we want to know the displacement, S. And we also know, what else do we know about this question? We know the acceleration. We know that the acceleration is due to gravity. It points downwards, as gravity always does. And it's 9.8 meters per second squared. So we can now think about SUVAT and what we have and what we need for this question. So let's write them all out and we'll figure out what they all are. The displacement, that's the one we want, isn't it? Because we want the height. And I'll tell you what I've just missed out, which I should tell myself off for, is we haven't decided which way is positive. So the ball is traveling upwards, so I'm going to take upwards as positive here. I'm going to take upwards as positive, so think about what's going to be negative. That acceleration is going to be negative, isn't it, because it points down. The initial velocity is 20 meters per second. That is upwards, so that's positive. The final velocity we don't know and we also don't care about, so we don't need this one. Acceleration is due to gravity, and that points downwards. So it's going to be minus 9.8 because of our upwards positive sign convention. And we know the time was 1 second. So I want the SUVAT equation without V in, okay? Now, that equation is S equals UT plus half of AT squared. We want S, so it's already set up for that. We've already got S as a subject, so we can just substitute in what we have. So U is 20, T is 1. A is minus 9.8. Don't forget the negative. You can see if you put the 9.8 as positive here, you get a completely different answer. So it's really important that you get the sign convention right in this one. If I put that in the calculator, I'm going to get 20 minus 4.9, and the displacement is going to be 15.1 meters. Just let me check that right, just in case my mental maths has let me down. Yep, we're all good. That's 15.1 meters. And that's your answer to part A. So it's by the time after 1 second, it's actually already 15 meters up. 20 meters per second is quite a high velocity, so it's already traveled quite a long way in that first second. Let's move on to part B now. So we want to find the velocity of the ball 3 seconds after it's struck and state whether it's traveling upwards or downwards. I'm going to draw us a new diagram. It's going to look very similar, but just to not confuse ourselves. This time, it's traveled for 3 seconds. We want to find the velocity. So we know it starts at 20 meters per second. We want to find out what the velocity is here, the final velocity. And we don't actually know whether it's upwards or downwards. It might still be going up. It might have actually turned around and started heading down by now. It might have got to the top and be heading back downwards. We don't know. That's part of the question. We know the acceleration is going to be downwards in 9.8 meters per second squared. The displacement we don't know and we don't really care about. So let's start writing out SUVAT. And we're still going to stick with the same sign convention. We're going to stick with upwards as positive. So write out SUVAT. Displacement, we don't know. It's not the height from before, by the way, because that was after 1 second. Now we're looking after 3 seconds. They're completely different. So we can't just use the same displacement. Okay, it's a completely different displacement. We can only reuse the initial velocity and the acceleration because they still apply. The acceleration is constant, so that always applies. And the initial velocity is the same because we're starting from the same point. We can't use that displacement again because it's after a different period of time. So S is just S and we don't really need it. U is 20 meters per second. V is what we want to know. The acceleration is minus 9.8 meters per second squared because we've taken upwards as positive, and the time is 3 seconds. So we want the equation with these 4 in. If you look back or look in the formula book, you'll find that's V equals U plus AT. We want to find out V. V is already the subject, so we can skip the step of having to rearrange anything. And now all we'll do is substitute in. U was 20 plus minus 9.8 times 3. Type that in the calculator. I get minus 9.4 meters per second as our final velocity. Okay, so what does that mean that it's got a negative? Well, I took upwards as positive, so that actually means that it's got to the top of its flight, turned round and started coming back down, and it's now heading downwards at a velocity of 9.4 meters per second. So that means this is heading downwards, okay, because it's got a negative sign. If we'd done this with downwards as positive, we would have got 9.4 meters per second as the answer, which is still fine because downwards is positive in that case. So we'd still understand that it meant that the ball was heading downwards. Okay, so we know it's traveling downwards and we know it's at 9.4 meters per second, which answers kind of both parts of part B, which is the velocity and whether it's traveling upwards or downwards, which is actually part of the velocity as well because velocity is a vector. And that's everything. Hopefully that those examples made things a lot clearer and made it easier to understand SUVAT and see where maybe you've gone wrong in previous times in SUVAT questions. We're going to move on to kinematics and calculus next time. So this is using differentiation and integration to move between displacement, velocity and acceleration and linking those things together again. But in that case, we can actually use it for varying accelerations, which is something we can't do with the constant acceleration equations. In the meantime, if you want more constant acceleration equations to test out and see if you've mastered this subject, have a look at the website at solve4x.co.uk. There's all the quiz questions and practice problem papers on there and a summary of everything we've been through as well. So check that out and see if that's useful to your revision. Hopefully I'll see you for the next video. Thanks very much for watching.